Hello guys, welcome to my channel. In today's video, we are going to learn about Docker. Since we are learning AKS and Kubernetes, Docker is a must to learn for that because we should have understanding of any of the container tools to ship to create our containers or pull the images or push the images. So you should have idea of containerized applications, and the Docker is the tool which we are going to use in our AKS or Kubernetes video series. Okay, so first let's learn about the Docker. So Docker is an open platform for developing, shipping, and running applications. If you see here in the Docker official documentation, Docker is enables you to separate your applications from your infra so you can deliver software quickly. Okay, so Docker is basically a tool to develop the Docker file, to build the image and deploy the container to any of the applications like on any of the tools like Kubernetes or even in Docker host. Okay, so you can ship your application inside a image and you can basically deploy that image to the hosting platform. Okay, so we will discuss about Docker in detail and let's begin. If you are in DevOps or if you are in software development, you might have already heard of Docker. Okay, if you also see the image, this is a ship and so many containers are loaded on it. So this is what Docker is called. This is a tool to ship the containers, and one containers can have one application. So let's compare this with traditional infra, like what was the issue in traditional infra and why we needed Docker. Okay, so if you see in the traditional approach, we had to create a server. So suppose this is my hardware infrastructure and suppose a Linux server or Windows server. So on top of that, we had operating system, and inside that we had to, and still we have to, install the libraries or dependencies or any softwares which we want to install for running our applications smoothly. Like in Linux web servers, you want to install app servers or some MySQL database, you want to install it. Then you will have to install each of the applications separately, okay, in that server so that you can run your software smoothly. And in this case, we had to do it every time whenever we had to deploy or we have to set up our applications. And if you have multiple environments like dev, test, or pre-prod and production, then you will have to do the same things. You will have to install the web servers again. You will have to install the libraries, dependencies, app servers, and everything again. Okay, so but in case of Docker, you can build one image. You can basically install all of it at once, and you can build the image. And later you can just run that image and your application will be running inside containers. Okay, so if you see here, installation and configuration, traditional infra is time consuming, and in that we need to perform or install all our configuration and dependencies on every server and every environment, that is dev, QA, staging, or production. Okay, need to keep resolving issues related to libraries and dependencies. So if we have some issues regarding dependency or libraries, we will have to I mean resolve dependencies, or you will have to resolve issues related with that. Okay, in traditional infra, it is very hard to track changes across dev, QA, staging, and prod environments, and they end up with, I mean, inconsistencies. Okay, so if someone is making changes, then it's very difficult to identify who made the changes. And if someone did something wrong, suppose they didn't install some libraries or probably some dependencies correctly, then it will break your change and it will be difficult to debug, or maybe you will have to troubleshoot the same issue each and every time. Okay, and for this traditional infra, of course, you'll have to invest on operational support. You need more resources to handle operational issues on day-to-day basis, because if you have installed so many dependencies, so many applications within a standalone servers, you'll have to hire resources to handle and manage or maintain those issues. Okay, because if you have some servers like this, you will have some issues and you will have to fix them, like uh, patching. You will have to do patchings and all. Okay, and if suppose you will have to set up separate environments for development teams, then it will be difficult. Like, see, for the developer environments, when a new developer joins the team, it takes time to provision his development environment in traditional approach, and it's time taking. Okay, so these are few of the issues which we have with our traditional infra. That's why everybody or most of the organizations now wants to move to containers. They want to use containers and deploy them to their to AKS or Kubernetes, or with in some another container orchestration tools. Okay, so now let's move ahead. We'll now check what is the difference between a physical machine and virtual machine. So how our softwares are being installed at the moment in physical machines. So in physical machines, suppose you have a single machine and hardware for that. On top of that, you will have operating system and libraries as well as dependencies installed. Okay, inside that physical machine, you will have web servers, app servers, and databases for your applications. Okay, and in case of virtual machines, you will have one hardware infra. On top of that, you will have hypervisor. Okay, after that, you will have virtual machines in one hardware infra. There can be multiple virtual machines, and again, the rest of the things will be same as our physical machine. In that, you will have operating system, libraries, dependencies, and your application. If we have web servers, app servers, and databases. Okay, and how Docker works in a physical machine. So simple, if you have a hardware infrastructure, suppose you have a machine in your own premises with some limited hardware, like suppose 150 GB RAM and operating system. On top of that, you will have to install Docker, that is Docker Container Runtime, and the Docker will be used to spin up your containers. Okay, and inside that you write Docker files, different Docker files for your web servers, app servers, and databases. So you write three Docker files and you create three containers for each of your uh, I mean components in your applications. Like web server is one component, app server is one component, and database is one component. So they will be independent of each other. Suppose if something is down, your web server container is down or corrupted, then you can just replace this container and you don't need to touch these two, because they don't have to, I mean, they are not dependent on this application. But in case of traditional infra, if something goes down, you will have to do all the setups, everything again, because they are dependent on it, and you will have to fix everything again. But in case of containers, these containers will still run if something is one of the containers goes down. Okay, and this is how we set up Docker in a virtual machine. Suppose this is your cloud provider and uh, they have some hardware infra in their data centers, and they have hypervisor as well. On top of that, they provide you option to create virtual machines in their infra, and create your own virtual machines. And they you install operating system and Docker on that. So inside Docker runtime, you create containers in each of the virtual machines, like how we do it in physical machine. Okay, you create containers with all the dependencies and libraries at once, and after that you just spin up the containers. You don't need to install all the libraries and dependencies again. Okay, just you have to build the image and uh, spin the containers with that image only. Okay, you don't need to install all the softwares or anything again. Okay, like the same you can do that in another virtual machine as well. Okay, these are all the advantages of Docker and containers. And if you someone asks like why we need to use containers, these are some of the advantages over traditional infra. So the first one is this is flexible. Even you can install, I mean, most complex application can also be deployed using containers. Okay, like take an example of microservices. If you have very large applications, suppose you take an example of Microsoft Dynamic 365. This is very large application that also can be deployed using containers, and they can be shipped with the help of containers. This is lightweight. Containers leverage and share the host kernel, making them much more efficient in terms of system resources than virtual machines. So if you are using virtual machine, then you will have to allocate resources to one of the virtual machines. Okay, so you will have to suppose 16 GB RAM and some memory like 1 TB. You will have to allocate it to that particular virtual machine. But in case of containers, you don't need to do that. They will run, you can take an example of a service. They will run like service, and they will utilize your resources. I mean, whatever they need, they don't use more than that. Okay, the containers are portable. You can build locally or in any machine, deploy to the cloud, or and you can run them anywhere. You can pull the image and you can deploy the image to anywhere in any machine or in any server as well. They are loosely coupled. If something happens, then you don't need to replace or upgrade all the containers. You can see here containers are highly self-sufficient and encapsulated, allowing you to replace or upgrade one without disrupting others. They are scalable. You can increase and automatically distribute container replicas across data centers. Okay, so basically you can scale your containers and you can create replica sets so that your application won't go down even if some of the containers in your replica set fails. Okay, this is secure. Containers apply aggressive constraints and isolation to processes without any configuration required on the part of the user. Okay, so they are since your application will be hosted in different containers, of course they are isolated in a virtual machine or in any of the environment, and they are secure. Now let's move ahead. We'll discuss about the container Docker architecture. Like what is the Docker architecture and how it works. If you see the diagram here, suppose this is a Docker host, you will have Docker client in it. This is optional. This can be inside your machine as well. The main thing here is Docker daemon. Okay, this will do everything. It will listen for all the API requests and it will do everything inside your Docker host. It will run your commands. It will do everything, run the containers and all. Okay, so you suppose this is a Docker host and you create images. You pull the images and you run the images inside this Docker host. Okay, and you spin up with that. You spin up containers with that image. So suppose image one is one image or some web server or something like that. You pull this image with Docker commands and with the help of Docker daemon, and that image will create one container. Same happens with another image or multiple images. You can pull multiple images and you can create multiple containers as well in that machine. Okay, if you see here the Docker daemon also called Docker D listens for Docker API request and manages Docker objects such as images, containers, networks, and volumes. So this will listen for all the API requests, whatever you are sending, and it will do accordingly. Like it will create objects, it will create containers and other things. Okay. Docker client can be present on either Docker host or any other machine. The Docker client is the primary way that many Docker users interact with Docker. Okay, we'll also know how we can install Docker client in our machines in upcoming videos. When you use commands such as docker run, the client sends these commands to Docker daemon, which carries them out. So suppose you are sending a command that is docker run, and this command is used to create the Docker containers. This will send the API request to Docker daemon, and this will spin up your container. The Docker command uses the Docker API. The Docker client can communicate with more than one daemon. Okay. Docker images. What is Docker image? An image is a read-only template with instructions for creating a Docker container. Okay, so we will have one Docker file where we will have to write all the instructions how you want to build your Docker image. Okay, and there is a command docker build to build image of from that Docker file. Okay, we'll see in upcoming videos how to write Docker files as well. So Docker file is basically an instruction to how to build the images. Okay, and once you run docker build on that Docker file, it will build an image that is called a image, and using that image you can directly spin up the containers. You can see the definition here as well. An image is a read-only template with instructions for creating a Docker container. Often an image is based on another image with some additional customization. So if you are writing a Docker file, you will have to uh, import one image, suppose a base image like Ubuntu. If you are using Linux, then you can, based on your requirement, you can import an image from Docker Hub. Okay, for example, we may build an image which is based on Ubuntu image but installs the Apache web server and run our application, as well as the configuration details needed to make our application run. Okay, Docker containers. A container is a runnable instance of an image. So once you run the docker run command on this image, it will create a container. Okay, so that is nothing but a runnable instance of your image. Okay, we can create, start, stop, move, or delete a container using the Docker API or CLI. We can connect a container to one or more networks, attach a storage to it, or even create a new image based on its current state. When a container is removed, any changes to its state that are not stored in persistent storage disappear. So suppose you have a container and you have some data in it, and you have not attached any files here or something like that, or some storage. Then if you have some data and if you remove that container, your data will be lost. So make sure you add I mean file shares or volume to your container if you are storing some data. Okay, so now move ahead. So this is a simple process how we pull the images from Docker Hub, and how we basically run the Docker commands. Okay, so if you see here, this is Docker host and this is our image. If you run the Docker pull command and this image, suppose nginx demos hello, this image is there in our Docker registry. Okay, if you run this Docker pull command, this will first reach to Docker daemon, and Docker daemon will again reach to Docker registry, and from there it will pull this image. Okay, it will pull this image and keep this in your uh, machine. Okay, and after that you run this Docker run command. It will again go to Docker daemon and it will check for this image, and it will spin up a container of this image. So this is Docker run command is to spin up the container. This is our port, this is container port, and this is a machine port, and this is the image name. This command should be run from our local machine or somewhere where we are running the Docker client. Okay, if you see the Docker registry or Docker hub, or Docker registry stores Docker images. You can create your own account as well on in Docker hub. Docker hub is a public repository that anyone can use, and Docker is configured to look for images on Docker hub by default. If you are not specifying any particular or private registry here while pulling your image, it will go and check this image on Docker hub. If this image is not found, you will get an error that this image is not found. Okay, so by default it checks in the Docker hub. We can even run our own private registry, that is okay. When we use the Docker pull or Docker run commands, the required images are pulled from our container registry. Okay, when we use the Docker push command, our image is pushed to our configure registry. So you have a suppose you have a Docker file, you build your own image from that Docker file, and you need to store that image somewhere in your registry. Okay, so you run Docker push command to push your image, or maybe a Docker tag command to tag your image first, and you can run Docker push command to push that image in your Docker registry, so that you can use that particular image later, or maybe someone else you want to share that image with, they can use that later. Okay, so that's it from today's video. We have covered about the Docker. We have seen how Docker can be useful. We have seen how what are the advantages of Docker. Okay, and we have compared this with traditional infra as well. We have seen the Docker architecture and some of the basic commands. We'll see other things as well, like how we can create the containers, what are all the commands in Docker, and how to install and set up Docker as well in our local machine. Okay, that's it. If you like this video, please like and subscribe my channel. If you have any suggestions or feedback, please let me know in the comments. Thanks for watching.